But not everyone has an abandoned mine system available in their region. So of course, network providers have to look for other solutions to make use of the 5th generation district heating and cooling technique. And we have 3 other pilots to tell us more about that. I'd also like to invite Nicolas and Lucas to come join us. In my excitement at the beginning, I did not call your names. But we will first, yes, Lucas and Nicolas. We'll first hear about 2 examples that are making use of thermal energy from sea and wastewater, the examples from Plymouth and Clyde. I'd like to first invite Jonathan to come up for Plymouth. Yes, thank you. Jonathan, can you tell us more about the system in Plymouth and how you are bringing the 5G elements into the system?
Yes, thank you very much. Very pleased to be here this morning and give you a very brief overview about the Plymouth scheme. There's lots of similarities with the other schemes in terms of it's an ambient network. But the distinctive thing about the Plymouth scheme is that the primary energy source, other than the recovered heat from cooling, because there are cooling loads on the network with the main 5 connections that you can see in the scheme, is that the primary heat source and cooling source is using the sea. But it's using the sea in quite an unusual fashion. I mean, history tells us many things, and in this particular part of Plymouth, there were existing wells supplying public baths, but also a brewery. They were very productive wells, but they turned saline quite quickly. We know that the well going, because obviously we're close to the sea, it's a coastal city, we're surrounded on 3 sides by the sea in Plymouth. And the brewery didn't use the water for brewing as they had intended. They used it for cooling the beer that was produced. They had to find a water source elsewhere. So we've been on a whole journey of learning about the geology of Plymouth through this process and learning how we can sort of harness that knowledge for heating and cooling in the future. So, and the pump testing, we've heard about other pump testing that's been carried out. This is quite shallow. We're drawing water up from 70 metres below the ground. We've been working with lots of geological organisations and getting some good advice, hydrogeologists, geotechnical advice about this to make sure that we get the solution right. But the pumping test, within 2 hours, we were drawing up saline water, obviously seawater, but filtered seawater. So you could say, why don't we use the sea directly? And that's something we probably will do in other areas. But this has some advantages in the sense that it's already filtered. We have less complexity than dealing with the marine environment with all the land ownership issues in the intertidal zone. So we're proposing to use an approach which is called, termed by our hydrogeologists, consumptive abstraction, where we draw the water out from the geothermal source and we put the water, after we've utilised it, back directly into the sea. We don't re-inject. That wasn't where we started from, but that's where we've ended up. And it seems to be a very good, viable solution. The one well that you can see in the picture there, obviously it looks different now, will supply that entire area, those 5 main connections. So, and we're looking at extra sources, extra wells to develop the network further over time. There's a secondary advantage as well in terms of climate change and climate adaptation. The geotechnical engineers are telling us, well, sea levels going up in these coastal areas, groundwater flooding, groundwater levels will also rise in many coastal cities. So actually pumping the water out may have a secondary advantage. So that could be win-win in terms of climate adaptation and renewable heating. So this is a brief schematic. I won't spend too much time on this because it's very similar to the other schemes, but you can see it's a decentralised approach. where the heat network acts like a balancing grid, effectively allowing waste heat to come into it from cooling, but also balance through the geothermal source as well. And we hope to introduce more thermal storage over time, but then using heat substations at the building level. And that might be one building, or it might be 140 houses, social houses in other cases. So we're using, again, reversible heat pumps where we can use the cooling and dump that back into the network. We're obviously also looking at exploring use of solar PV, either on the building level, in tandem with the heat pumps, or using a private wire network where we've got that infrastructure that exists. And we're thinking about how do we connect this into other networks, more traditional networks. This is a fourth generation system, also in the city centre. It's designed around heating primarily at the beginning, but quite challenging. We've all got challenging existing buildings. These are historic buildings, restrictions on how we can retrofit them. But we're looking at weather compensated approach to the heat network here to keep the temperatures as low as possible. It doesn't have to be 60 degrees all through the year. But it's been designed with air source initially, but the same heat pumps can also work in water source. So we can connect those heat pumps into the 5G system with time. So that's really where we want to be. It's not just maybe a variety of approaches, whether it's heating or cooling led over time, that can connect together. Thank you.
Great, thank you, Jonathan. I'll have you stay up here for a moment because we also have a question shortly about the flexibility in the system. But at the same time, I'd like to invite Hugh to come up and join us. Hugh, if you could grab the microphone that's there on the table, bring it with you. Hugh, it will tell us about the system. Will tell us about the system in Glasgow. So, Hugh, I give the floor to you if you can tell us briefly about 5G DHC in Glasgow.
OK, thank you. Bonjour, je m'appelle Hugues de l'Écosse, Glasgow. Je dois parler en anglais. Je suis désolé. Hello. I'm just going to speak a bit about wastewater, which is really which is really what we are focused on. There are a lot of similarities between the different projects, but our focus is using the wastewater system. In terms of the 5G DHC principles, we're looking at probably the first and the last one here in terms of what I'm going to be talking about today. So we also work in Clyde Gateway, which is the largest urban regeneration project in Scotland, which also has a very famous football team, Glasgow Celtic. And we also work in partnership with our public body, water body, Scottish Water. And one of the key focuses for us has been looking at the sewage system in the main urban areas and how we have looked to try and tackle accessing that energy. There are a range of complications around that, particularly in the first area, in terms of the heat recovery, because as you can imagine, there's a whole range of processes involved to get to a clean energy source. But one of the kind of key areas we've started to look at in Scotland is all of the wastewater treatment works. And these are the ready sources that are available for treated effluent. So the process has already been carried out. All we really need to do is access that energy. And one of the biggest attempts we've been looking at for connecting these areas is to look at how we can locate development essentially adjacent these energy sources. So this is our schematic for the Glasgow project. We're obviously using the wastewater and accessing the wastewater, treated wastewater, into the ambient loop. And similar to the other projects, we have decentralised heat pumps, energy substations, effectively using reversible heat pumps so that we can provide heating and cooling. And that energy source becomes a very constant energy source being delivered around 9 to 12 degrees. Seasonally it varies slightly, but mainly within that temperature range. So it's a good energy source, a very efficient energy source for enhancing that with heat pumps to deliver to new development. Critically, along with that, of course, is the introduction of solar and other elements to mitigate the electricity pricing, which is obviously a key component of making this type of system work efficiently and also commercially viable. So in our area, which is Kilmarnock Energy Centre, we do have this partnership, and this is a partnership that's being rolled out nationally within Scotland to increase the scalability of using wastewater. The flow rates are significant, as you can see. They probably average around 1,300 litres per second. So it's a very constant energy source, a very high potential that can be used, which can also then contribute to addressing cooling loads as well. But there are a number of key issues around that. The key ones are the grid connections, and I'm sure it may well be the same in the rest of Europe, but getting utility companies to work quicker, more efficiently, to provide grid connections, and there are obviously constraints in the network which affect that. But also for 5G DHC is the importance of trying to ensure that that becomes a key policy component. So the local energy strategies that we have to highlight how 5G DHC can contribute to the targets that were mentioned earlier for large-scale district heating. And that's a process that we are now doing with the legislation that's been recently passed to highlight 5G DHC now beyond even fourth generation, which is a very quick journey for us. And then finally, and probably most importantly, is the financial modelling. So as much as we can address the carbon emission reductions and the renewable energy sources, critically, the commercials must work. And that's part of that partnership that we have to work with Scottish Water, but using a very low commercial rate in terms of passive heat that's being generated from wastewater, and that helps to improve the commercial viability. But the key other component of that, of course, as I've mentioned earlier, is the solar connection or wind turbines or whatever we're going to look at in terms of mitigating that electric price as part of the commercial model. And that's what we hope will be rolling out over the next few years.
Thank you. Thank you. Thank you, Hugh. Did you have more slides yet to show?
Well, I think I'm calling for time, but I'm just going to show a quick picture of the abstraction system. So it's not very complicated. It can be very easily done, and it just extracts directly from the treated effluent. It doesn't need to be highly intensive from a capital point of view, but so there are options to mitigate the costs of that. Just a few slides.
Okay, thank you. You can stay here because you'll be part of the next session too. We wanted to focus this second session, of the pilot site on another aspect of 5G DHC. You've seen several examples here of how we can use low-grade energy sources to meet heating and cooling, and thus phasing out fossil fuel uses for heating and cooling demand. The systems that you've seen generally uses heat pumps, which are electricity consumers that can add a certain load to the electric systems, the national electric systems. Depending on the country, those electricities can be carbon intensive. And we know that for Plymouth and Glasgow, there is a plan of setting up PV panels. Could you please tell us a bit about that, how these PV panels meet flexibility challenges, and how do they improve your networks? So I think we have first Jonathan here.
Okay, I might invite my colleague Alistair down as well, if that's okay.
Of course.
Yes, I think there's a couple of slides, hopefully, which can illustrate the approach. Oh, great, thank you. So, Alistair, do chip in if you want. Yeah, we've got different scenarios. Where we've got an existing private wire network, we can clearly play a number of different, maximise the benefits of renewable capacity within that private wire. So this is an example where we've got existing buildings, I think 4 buildings connected by the private wire network, but also we've tried to expand the solar capacity by actually putting additional solar capacity on an adjoining car park, multi-storey car park. So we're trying to look at maximising the solar capacity, ultimately in trying to include some storage within that private wire network, so that we've modelled the future deployment of heat pumps within the connected to that private wire system, and align that with the solar resource. And you know, it can take pretty much all the solar we can put on there. But when we get to maximum solar, we need some storage, to add some storage in there to try to maximise the use of that solar resource. And that obviously helps us in terms of cost and carbon. So it reduces the carbon footprint. I think it's probably worth saying there's one other model where the City Council in Plymouth are also developing a solar farm, which is in Plymouth on a previous waste site, and we're also exploring the use of a virtual private wire where effectively we can account for this electricity to serve our buildings as well, which is a slightly different approach to an actual private wire. The other approach is an individual building. This is one of our buildings with a heat pump on there designed to connect to the network. You can see the solar on top. We've tried to maximise the use of solar, and again, all that solar has been used for that building and for the heat pump. So again, there's a good synergy. We can't do that with all buildings. We don't own all the buildings, but where we can, or using this virtual private wire approach, we can maximise the deployment of solar.
Thank you, Jonathan. So for Glasgow, I think there's also a couple of slides on the energy production that is expected. Sorry. I'll let you take the lead here.
Yeah, I think I do have a couple of slides in there somewhere, but I think originally we were going to be retrofitting the solar panels onto the buildings as part of our change, but one of the kind of key things which ties in with what John's saying is we are looking more towards having larger solar arrays as a permanent feature, essentially, because of the critical element it plays in the wider commercialisation of the model. So that's something that we're probably, although we will still retrofit onto buildings, there's a more direct role with some of the partners now to have large-scale ground arrays using more redundant sites that are connected to these sources where energy is being delivered.
Thank you.